All right, guys, so today we're going to talk about water quality, how abiotic and biotic factors affect our water quality, and how we can test for them. So, water quality is really important. It's important for us to continue to monitor the quality of our water for many reasons, and some of these reasons are humans and animals need clean water. We want our water supply to be clean enough to drink, to swim, and to use, and the animals need water that is healthy and can support them. So we have a couple pictures here of people using water for drinking and for recreation and cute little animals that also need it. So abiotic versus biotic. An abiotic factor are factors that are non-living, and biotic factors are factors that are living or they used to be living. So I have an image here for you, kind of like a wetland or a stream, and I need you to take a moment, pause the video with this image, and see if you can, one, define abiotic and biotic in your notes, and then pull out some examples of both abiotic and biotic factors in this picture. Now, for listening, we've written down some examples. You could have written some abiotic examples, things that aren't living in this picture. You could have had water, the sun, the temperature, if you were thinking about like if it's warm or cold out there in the wilderness. Air is abiotic, so if there's wind, that's also abiotic. If you notice there's some oxygen bubbles bubbling up from our little river there, or like pond, the oxygen is non-living, that's abiotic. We can do any of the animals in this picture are biotic. So the deer, the raccoon, the frog, the turtles, those insects, the plants are abiotic, the trees, the reeds, the lily pads, the fish, those are all biotic, sorry. Biotic examples, things that are living. Now, we are part of the Chesapeake Bay watershed. So what we do to our water, because the Potomac River flows into the Chesapeake Bay, affects the water quality for the Chesapeake Bay. So here's the report card for the Chesapeake Bay. Currently, this is as current of 2016. Overall, it has a letter grade C. So it used to be really bad, like D minus maybe, and then it has slowly increased over the years. So we noticed that the water quality wasn't good and people started to do something about that. Now, while you're looking at this, I want you to look at what letter grade do you think the area of Woodbridge, Virginia has. So remember what river flows into it. What letter grade did we assign that river? And then think about, why do you think some of those areas have better letter grades than others? So I see some B's, but I also see some D's. So why do you think there's a difference in these areas? So think about what you find along the rivers in those areas, if it's populated or not. And then take a moment, pause the video, and think about this question. Now, if you look at where we are from, we are in Woodbridge, and we know our water flows into the Potomac River. The letter grade we got was a C minus, so it's yellow, just like most of the Chesapeake Bay. And some reasons you might think that some areas have worse water quality than we do is those areas might be more populated, so the rivers are actually coming from more major cities like Baltimore, Maryland. Other areas might be recreation or national wildlife refuges, so that area is obviously more protected, so they might have a higher water quality letter than us. Things that affect the water quality is obviously pollution. So pollution is simply something that's introduced to the environment that's going to harm it or poison it. The two types of pollution you want to know about are point source and non-point source. Point source pollution is pollution where you can identify exactly what causes that pollution. So this is pollution you can point to and be able to say exactly where it's coming from. So some examples are industrial or sewage waste, oil spills, anything where you can clearly see where it's coming from. That's going to be point source pollution. So we have some pictures here of industrial waste, some sewage waste, and oil spill or a leakage from an oil pipe underwater. If there's a crack in an oil pipe and that pipe is leaking, you can point to that crack and say that is point source pollution. The other type of pollution is non-point source pollution. So a widely sourced type of pollution is this. So most of our pollution is non-point source, and that's because it's in the form of runoff. So I'm not going to be able to clearly point to where it's coming from, because runoff, it's going to remember, it's just going through the surface of our watershed, and it's going to be collecting and picking up things from everywhere, and it's all going to mix together. So because it's all coming from everywhere and mixing together in this runoff, we can't actually say where it's coming from. So that's non-point source pollution. That non-point source can come from farms, so agriculture. So we have a picture of it going through some crops in a farm, and we know that some people like to put fertilizer on their crops. Below we have some city runoff, and you can see like the really cool colors. That's oil. As cool as it is, it's probably not good to be drinking or getting into our water. That gets picked up by runoff. The picture between them has like urban development, city, suburban, rural, forestry, cropland, lots of farms with animals. If the animals are outside, all that like manure that the rain and stuff's going to go through is also going to be included in that runoff, and it's all going to get mixed together. And I'm not going to be able to look at that runoff and say that came from so-and-so's farm or that came from Jason's house. I can't say that because it's in runoff. So that's non-point source pollution. So I need you to take the video, or take a moment, pause the video, and in your notes, in your own words, I want you to compare and contrast point source pollution and non-point source pollution. And you should be able to write about 3 sentences there, and we'll share those in class tomorrow. Now, there are lots of ways we can test the water quality, and we're going to talk about 6 abiotic factors that we can test for. So remember, these abiotic factors are factors that are non-living. And we did several of these tests on our watershed field trip a few weeks ago, but just to review. One abiotic factor that we can test for is dissolved oxygen. So lots of living things need oxygen to survive, and dissolved oxygen, or DO, is the amount of oxygen that's been dissolved inside the water. So oxygen can get into the water in a number of different ways. The wind, when waves churn up like the water, it's putting oxygen in the water. Photosynthesis by aquatic plants, and they give off oxygen, or algae gives off oxygen, and that can get dissolved into the water. And aquatic animals breathe by filtering out that dissolved oxygen through their gills. Now, the more dissolved oxygen, the more abundant or more living aquatic things can live in that water. The lower the dissolved oxygen, the less oxygen's in the water, the less things can live in it. So we want our dissolved oxygen levels to be high, therefore more things can survive and thrive. So we have an image here showing you the range of tolerance for DO in fish, and you'll notice the higher the number, the more fish it can support, and as we get lower and lower, it makes it more stressful, they can't breathe as well, and the populations become lower too. The next abiotic factor we can test for is pH, or potential of hydrogen. This is a measure of how acidic or alkaline the water is. So usually I just think of how much acid is in the water. The pH scale is from 0 to 14, and if you remember, 7 right in the middle, that's neutral, and 7 is actually ideal for drinking water. It's ideal for lots of living things. Aquatic animals prefer to live in a pH level between 6.5 and 9. Anything below that becomes too acidic. When the pH is out of range for aquatic fishes that they find acceptable, it actually affects how they can reproduce and survive. And if it's way too acidic, they start to take in all that pollution through their skin and stuff. And you don't want that to happen, because then you're going to eat those fish, and now you're eating fish that is polluted. So it's really important that we also test the pH levels of our water, so we know that they're at a good level. The next abiotic factor we can test for is temperature. So this is simply the measure of how much heat energy is stored in the water. The colder the water temperature, the more dissolved oxygen it can actually hold. Now, aquatic plants and fish depend on certain temperatures to survive and reproduce. We have warm water fish and cold water fish. Here we have an example of some tropical fish, and then we have the Greenland shark. If we decided to take those two fish and switch them and put them in each other's ecosystems, the tropical one's now living in ice water and the ice shark is living in the tropical water, they would both die because they're not meant for those types of temperatures. So it's really important that we are always monitoring the temperature of our water. Turbidity. This is the measure of how cloudy the water is in forms of how much sediment is going to be mixed up in that water. So the cloudier the water, the higher the turbidity. And we have a picture here from low to high turbidity. On the left, it's low, it's crystal clear. That's some water I'm definitely going to want to drink. And then when I go to the far right side, it's super brown, very murky. I can't see through it. That's high turbidity. There's lots of sediments in that water, something I probably don't want to be drinking. We can use a Secchi disc to measure turbidity. So below that, I have a picture, has ABCD, and it looks like a little round disc that's black and white with triangles. We put that disc in the water, and if you can see it really clearly, we say it has low turbidity. But if we can't see it very clearly, the water is very murky, there's lots of things in the water, we can say it has high turbidity. So take a moment, out of these 4 images, A, B, C, and D, which one has the highest turbidity? And you should have chosen D because A is crystal clear, I can see it really well, and D I can't see very much at all. I can only see the 2 whites, the black triangles kind of start to disappear. That's meaning it's very turbid. Now, high turbidity is really bad for aquatic life. If there's lots of sediments in the water and you know fish and other aquatic things, they need to breathe by putting that dissolved oxygen through their gills. Well, as the water is going through their gills, if the water is highly turbid, so is all that sediment. So all the sediment and stuff going through their gills is obviously not healthy. We also have a picture here, and this is a real picture. I believe it's from Switzerland, of 2 rivers, one coming from a really crystal clear lake, and I can see really clearly through that water. And then one river, as it meets it, is very murky, and it's coming from a city that's high turbidity. I'd obviously want to be in the cleaner water versus that gross brown water. So just remember, turbidity is an abiotic factor that we can measure, and that's measuring how cloudy that water is. Nutrient content. So this is a measure of how much nitrogen and phosphorus is in the water, and we can find nitrogen and phosphorus in manure and fertilizer. A lot of nutrient content comes from people putting fertilizer on their lawn and from farms, so agriculture. It's important that we monitor how much nitrogen and phosphorus gets in the water because while fertilizer is really great and helps our crops grow, if the stuff that's in fertilizer gets into our water, while it helps stuff like on our land and crops grow, it's also going to help aquatic life and algae grow. So we get things called algae blooms, which leads to really bad issues. If we have too large of algae bloom, the algae is going to block the light, so it's difficult for aquatic plants to get the sunlight and do that photosynthesis. And when all that algae decides to eventually die, bacteria is going to eat that up. That's a natural process. But the more algae that's dead, the more bacteria comes in to eat that, and the bacteria is going to use up all the dissolved oxygen in that water to decompose the algae, which means the dissolved oxygen that the fish and the aquatic plants need is now gone, and they're going to die. So this just too much nitrogen and nutrients getting into our water can cause to really, really bad things, create dead zones where there's no oxygen in the water anymore, and just lots of problems. Now, the Chesapeake Bay, the watershed that we're a part of, agricultural runoff is the largest form of pollution found in the Chesapeake Bay. So Virginia's full of farms, Maryland's full of farms. Farms use fertilizer, they have lots of animals that produce lots of manure, and that runoff as it goes through these farms gets into the bay. And that's actually why the bay is has such low grades. We did a lot of too much runoff from farms and cities and stuff, and agricultural runoff is the largest form of pollution found in the Chesapeake Bay. There's huge dead zones caused by algae blooms that happened in the Chesapeake Bay, and we're working really hard to minimize that now. Salinity is an abiotic factor that we can measure, and it's very close to salt. It measures how many ions or salt is in the water. This test is also called the specific conductivity test. So the more salt in the water, the more conductive the water can become. And this test can help to indicate how polluted freshwater is due to the change in its natural conductivity. So we have a little dissolved oxygen or dissolved salt, chart here. The freshwater has very low conductivity, where ocean water has higher like salinity, so more conductivity. If there's a lot of pollution and the water becomes more conductive, in our freshwater, we know that the salinity is like higher. That means there's probably more pollution. We just want to know the level that it is originally and keep testing it every once in a while. And if the salinity changes, there might be an indication that there's pollution in our fresh water. Water quality tests that are biotic, so living. One major test that I find very fun is testing for macroinvertebrates. So remember, macroinvertebrates are animals without a backbone. We use a biotic index. So remember, bio means life. So a life index of these macroinvertebrates. We also call them benthos. So remember, bentho macroinvertebrates were invertebrates that hung out at the bottom of our rivers and lakes and the logs and the mud. And the biotic index has a scale. So we took the macroinvertebrates that we collect, we count how many we have of each, and then we use the scale to determine how polluted our water can be. So some macroinvertebrates are very sensitive to pollution. If you're finding macroinvertebrates that are very sensitive to the pollution, then our water is probably very healthy, because if the water is polluted and it's sensitive, it's not going to be able to survive. So if we're finding lots of macroinvertebrates that are can live in polluted water, they're not sensitive to pollution, and we don't find very many macroinvertebrates that are sensitive, then maybe our water is not as healthy. It might be a little bit more polluted. So looking at the type of animals or macroinvertebrates that live in the water can help us determine how healthy our water is. Now, as a review, I want you to try and identify the water quality test based on the scenarios below that you would be testing for without looking at your notes. So when you're done, I want you to put a check next to the questions you got wrong after you check your questions. We're going to go over them in class tomorrow. So the scenarios are these. Number 1, what test would you use to test the clarity of the water? 2, what test would you use to test the amount of salt water in an estuary or the pollution levels in fresh water? Scenario 3 is, what test would you use to see who can breathe underwater or how well they can breathe? Test 4, how warm or cold the water is. Test 5, what test would you use to test the pollution level of water based on the animal diversity in the water? Oh, there's a typo there. Well, test 5 point number 2, the second 5, what test would you use that tests the level of nitrogen and phosphorus from agricultural runoff? And test 6 is the level of acidity of the water. So what test would test that? And when you're done with that, I need you to answer these questions. What type of pollution do we find the most in the Chesapeake Bay, and where is that pollution coming from? And question 2, what do you think we can do to improve the quality of our water? And we'll discuss all our answers tomorrow in class.